Okay, let's discuss some key concepts in R. First thing that we need to know is that R is RAM dependent, which means that R runs entirely in RAM, as opposed to other statistical software that may run in local hard drive. If you want to use big data analysis and run analysis of millions and millions of cases, you really need to provide a lot of RAM. In our lab, for example, where we have models that run across the US at a very high spatial and temporal resolution of daily 100-meter predictions, we have millions of observations, and thus we have to use clusters and high performance machines. The advantage of using RAM in statistical application is that it's blazing fast. If you compare it to other analysis you do in other statistical software such as SAS, it's much faster once you have the adequate requirements. Moving on to scripts. R scripts, like any other program language, is a text file, usually with the .r extension, and it contains all your R code. It is a complete record of all the analysis when you write scientific-oriented scripts, and it's very reproducible. That is, running your code is very easy for you or someone else to do. You can share your code with colleagues. You can have other people review your code. That ties into reproducible science. It's easy modified and it's easy to rerun. If you compare using GUI based applications such as Excel or SPSS, where you have to click on many GUI options and then it's much harder to remember and reproduce, once you have a script, it's very easy to reproduce and modify and rerun your code. So in RStudio, you can select pieces of code and then either press Control Enter to run the code or manually run it via a button. Let's show an example. We're going to open RStudio. We're going to go again and create a new script. And we're going to use a very simple command, x equals 1. We'll discuss what this means a bit later. But I can either mark it and evaluate it by pressing the run, or I can mark it and press Control Enter. And this will also run the same command. Finally, it's very important to save your scripts. RStudio is not like Word or other text editors. It won't automatically save your work. So before closing down RStudio or to protect yourself in case of a failure, make sure you save your code every few minutes. Another very important topic is R is case sensitive. That is, input with a capital I or input with a lowercase I or input all capital are very different in R, meaning that commands that are or variables that are written in different cases will either work or not work based on what you've written. R workspaces. When you close your R session, you can save data and analysis in an R workspace. This saves everything you run in the console, and I generally don't recommend it. The reason for not saving your workspace every time you shut down R is that when you work with serious big data analysis, when you have millions of vectors and millions of cases in these data tables, it can get very big and it's going to take a long time for you to save the data, and even more critical, it's going to take you a long time to load the data when you start again. So I prefer not to automatically save the workspace and load them, but start with a clean database and just load the specific data that's needed. But there is an option if you don't work with enormous data sets to save your workspace and load it again once you leave or come back to RStudio. Also, there's a command to clear your workspace. If you want to start afresh without restarting R, you can clear your workspace. There's several ways of doing that. One of the easiest ways of doing that is using this broom icon. So this clears all objects from the workspace. So if you see if I can hit it, it's going to ask me, do you really want to remove all objects from the workspace? And if I say yay, yes, all objects are removed, I go back to clear workspace. Let's move on towards some programming basics. Okay, the R interface is divided into different sections, as we've seen before: the script, the console, the environment, and then the different components such as files, plots, and so on. In programming, when we code, we usually use a script. And code or source code refers to the sequence of instructions in a program or a script. When we say syntax, that means the set of legal structures and commands that can be used in particular programming languages. It differs from programming language to programming language, such as the difference between the syntax of Finnish and German and Hebrew and English. There's going to be differences between each syntax. In general, a lot of the things are very similar. For example, Python and R both use hashtags for comments and so on, but each time you learn a new program language, you should learn the correct syntax. Output is the messages printed to the user by the program. Console, as you've seen before, is a text box or a panel where all our output is printed. Some source code editors pop up the console as an external window, and others contain their own console window. In R, as you can see, you can either have it embedded, or you can even increase the size or decrease the size based on your need. Let's look at our first R command, and this is also an opportunity to look at the case-sensitive topic we just discussed. Let's open RStudio. You can either pause this video and do it yourself or follow me in the video. And to get a description of the version of R that we're using, we can use a package or a function that's available natively in R called session info. So we can copy session info. You can write it by yourself. Notice here that the I in the above command is capitalized. Okay? Let's go back to R and enter the command session info. Again, to evaluate, I mark it, and I either press Control Enter or I press Run. Notice that now I'm going to get the output in the console. I can make it bigger. I'm going to see the version of R, the OS I'm using, the version of the OS I'm using, which packages are loaded, which locale I have. And this is very useful. Specifically, the version number is critical because some packages are tied specifically to version number. So it's a very useful command to get an overview of the state of the current R session that you're using. Notice that if I use a lowercase I and evaluate that command, I'm going to immediately get an error. As I said, R is case sensitive. Keep that in mind if you get errors to check your syntax. Moving towards more examples on R programming. R code can be entered in the command line directly or saved to a script, like we just did, which can be run inside a session using the source function. Commands are separated either by a new line, so a complete new line is a new command, or by other types of breaks, which we're not going to discuss now. Help files for R functions are accessed by preceding the name of the function with a question mark. This is also important. This allows us to look at any function that we're unsure about and really get into the details of what does that function mean. And let's issue our second command now in R. We're going to go back to RStudio. We're going to use question mark mean. Mean is the arithmetic mean of a vector or a series of numbers. If I run this, you'll see that on the helper panel, the arithmetic mean help file opened. I can use this little pop-up sign to enlarge it and make it center screen, and I can read about the general function of mean, what it does, that is the arithmetic mean of a vector. You can see examples, you can see the arguments available, and at the bottom some working examples on how to calculate a mean. Very similarly, every function that's available can be called through this help file. So if I want to now look at the sum and not the mean, I can evaluate that in the same way, and I can get the sum of vector elements help file. Okay, let's shift over to talk about packages. You've seen already that there's packages included in R in the base installation, but even though the base installation of R comes with many functions already defined, you can really increase the power of R by installing thousands of additional packages. Once you get a bit more experience with R, you may want to define your own functions to perform tasks that are specific to your goals. So as we've shown, there is a way to extend R, and that's through packages. The packages are collections of R functions, compiled code, and sample data. So it could be even data sets that you can add. They are stored under a directory called library in the R environment. And they can add additional functions such as graphics, such as statistics, JS, and much more. You'll see that as we advance in the course, we'll install more and more packages that will help us extend our capabilities. For example, a big graphic enhancement is using the ggplot package, which we'll learn later on. By default, R installs a set of packages during the installation. More packages are added later on when they are not needed or are needed for some specific purposes. When we start the R console, only the default packages are available by default. We've seen that when we issued the session info command, it shows us the default packages being installed, such as stats, graphics, base, methods, and datasets. Other packages which are already installed have to be loaded explicitly to be used by the R program that is going to use them. And we'll see how we do that in a bit. How do we extend and get even more packages? A repository is a place where packages are located so you can install from the repositories. Typically, they are online and accessible to everyone. There are three major repositories for the R ecosystem. One of them is CRAN, the official repository. It's a network of FTP and web servers maintained by the R community across the world. We even have some packages from our lab in CRAN. Dr. Michael Dorman led the development of a package called Shadow to look at photovoltaic calculations, and we submitted it to CRAN, and it's there. You can go and download it. The R Foundation coordinates it, and for a package to be published there, it needs to pass several tests that ensure that the package is following CRAN policies. You can even get more details if you go to the CRAN website if you're interested. But there's additional repositories for R packages. One of them is Bioconductor, which is really aimed at bioinformatics. Usually we don't tend to use that in geoinformatics that much, but a huge repository is GitHub. Although this is not R specific, GitHub is probably the world's most popular repository for all types of open source projects, including R. Its popularity comes from the unlimited space for open source projects, the integration with Git, which is a version control system, and its ease to share and collaborate with others. But be aware that there's no review process. So 99% of the time, these are academics putting in these packages, but make sure that you know what you're downloading. More on GitHub and version control system in the next semester in the ADS course. I know I mentioned the ADS course a lot in the first lecture. It's not going to continue throughout every lecture, but this is an introduction to a lot of the extended capabilities that, if you're interested in learning, will be available in the ADS course. So the next command we're going to cover that help us work with packages is called libpath. To get the library location containing the packages that you have, you can issue the libpath command. If I go back to RStudio and I issue libpaths, you will see on the bottom that all the libraries and additional packages are going to be installed in this specific path and this specific folder. This is going to be different from each computer to computer based on the definitions that you have. Okay, so how do we install packages? We've talked about, being able to extend packages. There's basically two ways to do that. One is through the graphical user interface, the GUI, and we can look at LME for an example. The other way of installing is by using the command line. We can use the function called install.packages, give the name of the package, and that will install the package. Let's look at an example. I'm going to the package pane, okay, and I'm going to look for a package called LME. I'm going to press install, and then I'm going to put in LME, and you can see that it gives me all available packages with LME. If I press LME4 and click install, notice R is going to go out, download the file from the CRAN repository, and install it. Another way of doing it is using the install.packages and issue LME and evaluate that, and the same thing is going to happen. It's going to go on to CRAN, download the packages, and install it. So that's very simple. it's critical to know that even though that we've installed the package, if we need a specific package for our current R session, we must load it into R before starting to use it. And you can do it again, either via the GUI or via the command line or script. So if I go now here and I look for LME4, if I click on the sign or if I checkbox the LME4, it's gonna load the package. Similarly, I can just issue the library command and write LME4, and again, it's gonna go out and load the LME4 package. So two ways of loading packages. Once the packages are loaded, you can go ahead and use these packages. Let's shift to talk about working directories. The working directory is the default location where R will look for files you want to load and where it will put the files that you save. One of the great things about using RStudio and RStudio project specifically is that when you open a project, it will automatically set your working directory to the appropriate location. You can check the file path of your working directory by looking at the bar at the top of the console pane. Note also that the tilde symbol above is a shorthand Unix way to define the home directory. Another command that's useful is called getwd. You can use that command or function in the console, which returns the file path of the current working directory. So if I mark this and paste it over here and issue the command, it's going to show us that the working directory currently is my user account. Again, this is going to be different from computer to computer. The set working directory allows you to set a specific working directory where you want to have all your scripts and functions saved. So you can set setwd and give it a path, okay? And then all the information and all the scripts, analysis, and so on will be saved in that specific script. However, the problem with setwd is that it uses absolute file paths. You may know this from previous courses using ArcGIS, that if you use absolute paths and you want to send your script or data or shapefile to someone else to collaborate with, your boss, your advisor, then they're gonna get errors when they try to open it. So keep in mind that if you set the working directory, that entails some issues down the road. Okay, let's go and now discuss directory structures. In addition to using RStudio projects, it's also very good practice to structure your working directory in a consistent and logical way to help both you and your collaborators, or bosses or mentors again, to find data easily and just be able to traverse the file system and the project more easily. This is one example of a good common directory structure. This is something that I use and we use in our lab, but you don't have to use this specific directory structure, even though it's quite common in academic research. What does that directory structure have? It has a root folder. This is where your project directory is. This is where you can use setwd to create the working directory. And this is where your R project file, if you're using R projects, sits at. We have a data directory where we store all our data, and the subdirectory is there, sometimes called raw data, contains data that is primary data, which is data that you've obtained either through the USGS, NASA, the Ministry of Environment, data that is primary, and you're going to do the analysis on this data. If you need to modify, clean, change this data, never touch the raw data. Save the new data in a processed data directory. That way you still have an original copy of the primary data in your root directory. Finally, there is a metadata directory, which you can add documentation and information about the specific datasets. Then we have an R directory. This is an optional directory where we save all the custom R functions that we've written for the current analysis. This can later be sourced by using the source function, which we'll learn down the road during the semester. You can have an RMD file, which is an optional directory where we can save our markdown documentation. You can have a scripts file, where all the main R scripts that we have written are nested in a subdirectory, or you can just save your scripts in the R directory. And finally, it's quite common to have an output directory, where outputs from our R scripts such as plots, HTML files, and data summaries are saved in this directory. This helps us and our collaborators distinguish what files are outputs and which are source files. Of course, the structure described above is just one of the structures that can work, but every person has its own philosophy, an own view of how to structure their own files. We tend to have a fairly consistent directory in academia, as you see in a cross project, which allows us to quickly orientate ourselves when we return to a project after a while. Having said that, different projects will have different requirements, so we happily add and remove directories as required. You can create your directory structure using Windows Explorer or Finder on the Mac, or using RStudio by clicking a new folder and then the Files pane. Commenting. The pound sign is a critical thing to learn in R, and commenting in general is very useful. The pound sign, sometimes called hashtag for the younger generation, starts the beginning of a comment. So if you have the character at the beginning of a line, this signifies to R that this is a comment and you should not execute this command. Everything that starts with a pound comment and the rest of the line after that is ignored. For example, when we look at our session info command, if we add a pound sign, R will ignore that line when it evaluates code. Let's look at an example in RStudio. If I go now and I use pound sign getWD and I evaluate that, nothing is going to happen. I can even add text such as this is a command to get blah 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 blah. I can evaluate and nothing will happen because this is not evaluated. If I take out the pound sign and I evaluate that, obviously I'm going to get an error because this is not proper syntax. So commenting allows us to add vital information, and it's good code practice to write a little comment above every little command or model that you do to help you then remember and share this code with others. So I can go, this gives session info. Okay. Another key aspect is entering input assignment operators. This is used, and we've seen that slightly before, to assign a value to a name or an object. At the R prompt, we type expressions. The smaller than dash, or more commonly these days, the equal sign or symbol, is the assignment operator. For example, if we want to assign 1 to the object x, we can use x smaller than dash 1. And then we can print the value of x. And then we can even assign character variables to the variable that of interest. Let's look at an example. I can use either the smaller than or equal sign to assign the value of 1 to x. I can use the print function to print what is in x, and I can even assign character variables or character data to a variable by quoting it. We'll learn about the difference between numeric and character next lesson. But as you can see, assigning is a critical aspect of writing code. And as you saw, when we complete an expression, we can evaluate it and get information about all the processes that we just entered. To note, the little 1 with brackets indicates that x is a vector. It currently has only one object. And 5 is the first element of that vector. If we had more data, we would get more numbers. Let's talk about how R stores data. R stores both data and output from data analysis, as well as everything else, and objects. Things are assigned to and stored in objects using the operator that we've just learned about. A list of all objects in the current session can be obtained using the ls command. If we go back to R now and we issue ls, we will see that we currently have the message object and the x object that we previously defined. Okay, That will wrap up the first lesson. I hope this was of interest to you, and we'll continue next week diving further into R. Thank you.